Hello everyone. So today let's solve the problem number 1462 course schedule 4. So we have already solved course schedule 1 and 2, right? So today we'll be solving course schedule 4, right? So let's see what the question states here, man. So let's come to the example part here. Yep. So we are given num courses here. Yep. We are given num courses, right? So, and a list of prerequisites as usual. So we have solved 1 and 2. We will be given number of courses and prerequisites itself. So prerequisites, we have 1 comma 0, right? Nothing but prerequisites pairs A comma B, meaning we must take the course A before course B. Here in this case, we must take the course A before course B. Usually for the 1 and 2, we were given actually, we have to take the course B before taking the course A, right? So for a change, what they have asked here. So we have been given number of courses. Along with that, we have been given prerequisites as well. We have to take the course A before taking the course B. Yep. So we have to take the course A before taking the course B, right? For each query, for a change, they have given queries as well. Along with the number of courses and prerequisites, we have been given queries as well, right? So for each query U comma V, U comma V. So this is U and this is V. U comma V is nothing but the nodes actually. You can just consider this one as the edge from 0 to 1. Yeah, from 0 to 1 actually, right? So this one they have mentioned in this one example. See, 0 to 1 actually outgoing this one. What do we call? In degree of 0 is 1 and in degree of 1 here is nothing, 0 actually. Yep. So each for each query U comma V, we have to determine if U is directed or indirect prerequisite of V. What we need to determine again, we need to determine if U is a direct or indirect prerequisite of V. U, this one 0 is a direct or indirect this one, what do we call? Prerequisite of V, nothing but 1. 0 is direct or indirect prerequisite of 1. That's what we have to determine actually, right? So here what we need to return, we need to return the list of booleans where each entry corresponds to whether U is prerequisite of V, right? Again, we need to return the list of booleans where each entry corresponds to whether U is prerequisite of V, right? So the graph has no cycles. Just remember, they have strictly mentioned that the graph has no cycles. Yeah, so this is the question, man. Simple one. Let's come to the example one here. See, number of courses we have been given 2. Prerequisites we have 1 comma 0. We have to complete course 1 before completing the course 0 accordingly with the question, and the queries we have been given 1. All we have to determine is if 0 is direct or indirect prerequisite of 1, right? Accordingly with the question. Yep. So here the pair 1 comma 0, this one, the pair 1 comma 0 indicates, so we have queries, two queries here. One is 0 comma 1 and 1 comma 0 actually. The same goes with 1 comma 0 as well. Yeah. So we have to determine whether this one 0 is direct or indirect prerequisite of 1. Also we have to determine 1 is direct or indirect prerequisite of 0, vice versa, right? So this is fine. The pair 1 comma 0 indicates that you have to take the uh, course 1 before you can take the course 0, right? So that is possible because the prerequisites we have been given 1 comma 0, 1 comma 0, right? So we will be taking the course 1 before taking the course 0 accordingly with the question. But here we have been when queries 1, meaning so we have to take the course 1 before taking the course 0. Here it is not possible, right? So here we are asking us to, they are asking us to take the course 0 before taking the course 1, but the prerequisite states that we have been given 1 comma 0 here. So the pair 1 comma 0 indicates that you have to take the course 1 before you can take the this one course 0. For this one we will be going with the true, right? So for the 1 comma 0 we'll be going with the true. It is possible. But for the 0 comma 1 we have to take the course 0 before 1, which is not possible accordingly with the prerequisite they have given, prerequisites that they have given in the question. Yep. So course 0 is not a prerequisite of 1, but the opposite is true, right? So here in this case it is not possible, so we have to output boolean value false. So here in this case false and true, right? So this is how we got false and true. Same goes with example 2 as well, man. You can just look into it. Yep. So you can just look into it. So the same thing goes with example 2. So now we have the idea on the question. So they have given us wonderful examples just for the sake of understanding. Yep. So they have given us wonderful this one example just for the sake of understanding, right? So now let's do one thing. Let's hop into the approach part, right? So before hopping into the approach part, let me tell you that we will be solving this problem by making use of the Floyd Warshall, right? So usually we call this one as transitive closure, right? So if you know that we usually say this one, right? If A belongs to B and B belongs to C, A belongs to C. So that's what we call it as transitive closure, if you remember, right? So if you remember the transitive, what transitive closure is, right? If A belongs to B and B belongs to C, then A belongs to C. So we will be going with a Floyd Warshall, nothing but transitive closure. Let's see how we will be solving this problem. Yeah. So just remember, we'll be going with a Floyd Warshall to solve this particular problem. So if you don't know the Floyd Warshall algorithm, again I am telling, so I can just go to the this one graph based playlist. So there we have discussed the graph based algorithms. Yeah, there are many algorithms, whether it may be Floyd Warshall, whether it may be Dinick, whether it may be Bellman Ford, whether it may be Dijkstra, whether it may be Johnson's algorithm, any algorithm. So we have discussed most of the algorithms, around 20 algorithms, 19 to be exact, I believe. Yeah, around 20 algorithms we have discussed, to be frank. So you can just go through the Floyd Warshall algorithm and then you can come. Yeah, so that you understand the this one solution clearly. So you will be knowing the implementation, right? So you can implement very quickly if you don't, if you know the algorithm actually. That's what I want to say. Yeah, that's what I feel. Yep. So now let's consider the same first example. So we'll be going with the Floyd Warshall. Just remember transitive closure. So this one, this is fine. Yep. Let's consider the same first example. This one actually. Yep. So see, number of courses we have been given 3 here. Or let's do one thing. 1 second. Let's do one thing. So what happened here, man? 1 second. It was stuck. Let's consider this one. We didn't discuss this one at all, right? So let's consider this one actually. Yeah, example 3 actually. Example 2. Oh, in the middle they have given example 2 as well. Yeah, this is false actually. Rather than this one, let's consider this one, example 3. Yeah. Instead of the example 1, for a change, let's consider example 3 here. This is fine. Number of courses we have 3, and the prerequisites we have been given 1, 2, 1, 0 as well as the 2, 0. Yep. So 1, 2, 1, 0 as well as the 2, 0. Query we have been given 1, 0 as well as the 1, 2. Yep. So this is fine. So we will build the directed graph, man. We will build the directed graph. First thing they have given here, 1 second, prerequisites based on the prerequisites, right? This one 1, 2, 1, 0 as well as the 2, 0. They have already shown the diagram here. 1 to 2. So this is the directed graph. I don't have to draw the graph again, right? So 1 to 2. So this is directed. 1 to 0. See here. This is directed. And 2 to 0. Yep. So this is directed. Yep. The arrow mark you can see, right? So this is fine. Yep. Now let's create the 2D Boolean array matrix. Nothing but let's go with is pre here. So is pre is nothing but the variable. Don't get confused here. Is pre of I and j, right? Is pre of I and j. Let's consider this one. So is pre of I and j is only true if I is prerequisite of j, right? If I is prerequisite of j. Initially, let's set the true for direct edges. Yeah. So let's set the true for 1, 2, 1, 0 as well as the 2, 0. Meaning, so this one. For this one, 1, 2, let's set this one to 0. 1, 0, let's set this one to the 0. And 2, 0, we'll set this one to the 0. Right? So initially, we'll set true for the directed edges, nothing but is pre of 1, 2, let's set this one to the true. Is pre of 1, 0, let's set this one to the true. And is pre of 2, 0, let's set this one to the true as well. Now, after doing this, all we have to do is we have to apply the Floyd Warshall, nothing but the transitive closure. When I said transitive closure again, so here in this case we have I, j, k, right? So here I can just consider in this way: if I belongs to k and k belongs to j and k belongs to j, then I belongs to j here. Then I belongs to j. I belongs to k and k belongs to j. Then I belongs to j here. So this is the transitive closure. We know this one, right? So accordingly with the example here, if 1 belongs to 2, right? If 1 belongs to 2 and this 2 actually, this 2 belongs to 0, this 2 belongs to 0 actually. Now 1 belongs to 0, right? So 1 belongs to 2, 2 belongs to 0 and 1 belongs to, so 1 belongs to 0, right? So 1 belongs to 0. Here from 1 to 2 and 2 to 0, we infer 1 to 0, nothing but already true here in this case, right? For each query, we simply check is pre of node u and node v respectively, right? So this is already true. In this case, we will be this one. We'll be going with a Boolean value true and true respectively. We'll be going with a Boolean value true and true respectively. Very simple one. Yeah, true and true respectively. So the output that we got here is true and true comma true, which is equivalent to the output that they have mentioned for the example, this one 3 within the question, right? As we are completely familiar with the approach, now let's discuss the complexities part, man. So what will be the time complexity actually? The time complexity would lead to big O of n cube plus q. It's a Floyd Warshall, usually it's big O of n cube. So we will be going with a, we have to go with the queries as well, right? So it will be big O of n cube plus q. Floyd Warshall for the n courses plus q queries we are considering. So it will be big O of n cube plus q, right? So this is fine, I believe. So what will be the space complexity here? Space complexity is just n cube because we'll be storing the prerequisite relations in a 2D matrix in the 2D matrix. So overall space complexity would lead to big O of n cube. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n cube plus q and big of n cube respectively, right? So now, as we are completely familiar with the approach as well as the complexities part, we are good to write the code. Let's start writing the code. Yep. First step, let's do one thing. Let's create the adjacency matrix. Nothing but is pre of ij is equivalent to the true, means I is prerequisite of j. So I'll just go with Boolean here. This one, let me go with is pre here, new Boolean. So let me go with the number of courses here. This one. Let me copy this one and paste it over here. And also let me go with the number of courses again, man. So let me paste this one again. Yep. So we have successfully created the adjacency matrix, nothing but is pre of ij is equivalent to the true, means I is prerequisite of j. That's what we discussed in the approach, right? So now let's do one thing. What was the step two? We have to fill the matrix for the direct prerequisites, right? So let's move on with the for loop, or let's move on with the iteration part here. So this one will be int p of prerequisites. So let me copy this one here, paste it over, right? Prerequisites. So within the for loop, let's do one thing. I'll just go with is pre of is prerequisite of this one. What do we call p of 0? This is fine. And now p of 1. So this is also fine. Yep, somewhere I did something wrong, man. Yeah, let me remove this one and let me give here. Let me close the square bracket here. Right, so this is fine, man. Yep, let me set this one to the true actually. Let's set this one to the Boolean value. Yeah, so let me come out of this one entirely. Now what shall we do? Let's make use of the Floyd Warshall logic, right? Nothing but the transitive closure. That's the just now we had discussed the same thing actually. Let's make use of the Floyd Warshall logic here. Nothing but transitive closure. Transitive closure in the sense I belongs to k and k belongs to j, then I belongs to j, right? So let's go with the for loop. So this one in k equals 0, k less than number of courses. Sorry, did I copy the prerequisites? I'll just copy the number of courses here. So this is fine. Let me increment the k. Yep, simple. Now let's go with for int I equals 0, I less than again number of courses. So I'll just go with I plus plus. Yeah. Now let's write the simple if condition for it. So I'll just go with if pre of I and k here, pre of I and k, if I to k exists, meaning if I belongs to k exists, then let me go with one more for loop here and j equals 0, j less than number of courses here, and let me go with j plus plus. So within this for loop, so and k to j exists. If first we have checked whether this one for this line number 11, we are checking if I to k exists. Now we have to check whether this one k to j exists. So if I to k exists and then k to j exists, then only I to j exists, right? Let's check whether k to j exists or not. So let me go with one more if condition here is pre of so this one k as well as the j. This is fine. Yep. Now within this if condition, then I to j is also true, right? So how can I write this one? Is pre of I j. So this one, let me set this one to the true actually. Let me set this one to the true. Yep. So let me come out of this one entirely. Yeah. So we are done with the we are done with almost all the things. For each query, we have to just check the matrix, right? So let's write that one quickly. So we cannot skip this one. Let's just go with a Boolean. So let me consider, sorry, go with list here, Boolean. So I'll just go with here the result. So this is fine. New array list actually. This is also fine. Yep. Now for this one, int queue of queries, right? So where is queries actually? Let me copy this one. Uh, Let me paste this one as well. So within the for loop, let's add, what do we need to add to the result actually? Is pre of query of 0 and query of 1, right? So I'll just go with here is pre. Let me copy this one here. So this is fine. Mm, Q of 0, Q of 0, this is fine as well. Then let me go with Q of 1 as well. Yep. So Q of 1 as well. Yeah. I did something wrong somewhere. Q of 0 is fine. Let's have closed. It's fine. Let me do one thing. Let me open one more square bracket here and let me close this one. Yeah. So this is fine, man. So now let's do one last thing. Nothing but we have to return the this one final Boolean list, right? So that is stored in the result variable, result itself. Yeah. I'll just go with a return result. Yeah. So we have successfully written the code. Let me format the code and let me hit the result button. I'm confident that this will be correct. So I'm hitting the result, this one submit button directly. Let's see. Yeah, all the test cases are getting passed here, right? So whatever the code that we have written works absolutely correct for all the test cases here, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.